Okay, today the focus of lecture was on the concept of similitude. The idea underlying similitude is that if we design experiments carefully and correctly, we can then ensure that the physics remains the same. We start in understanding similitude with dimensional analysis. I want to emphasize here common dimensionless groups that represent specific force balances. So we have the Reynolds number, which is the ratio of inertia to viscosity. We have the Froude number, which is the ratio of the fluid speed to the wave speed. It also represents the influence of gravity. The Weber number is the ratio of inertia to surface tension. The Mach number is inertia to elasticity. And then the coefficient of pressure is pressure over inertia. It's the only one that places inertia in the denominator. Now the idea of similitude is to say that if we have something at the field scale, or the real scale, say we have REF and other dimensionless groups, and then we want to design a model which will be characterized by a Reynolds number, say REM, then similitude is ensured by the Reynolds number. It's dragging around. What happened? The Reynolds number for the field scale has to be equal to the Reynolds number for the model. If that is ensured, then we can design experiments, and then we can use the results from the experiment to understand how things behave at the field scale. Going back to our example from Monday, where we had the drag force is equal to rho u0 squared d squared times some function of Reynolds number, an aspect ratio, and a second aspect ratio. If we have the same Reynolds number, the same aspect ratios, then similitude ensures that this function, so if we match these three groups, match field and model scales, then what similitude tells us is that this underlying function that we determined from experiment is the same at various scales, so equivalent across scales, which means the underlying physics is the same as we change scale, as long as we ensure that those dimensionless groups are the same. So similitude here, I want to make this clear. I guess the way this looks on the screen. Similitude doesn't necessarily require Reynolds number equivalency. That's one example of similitude. We could also think of similitude in terms of Froude number, Weber number, Mach number, etc. The key thing is that whatever the dimensionless groups are that are important for a particular problem, that they are preserved in going from the field scale to the model scale.